This video is about how to find second order derivatives. So underneath your last bit of work, can you write the title and you can read the learning objective to yourself. Pause the video so you've got time to do that. Now if we take a function, let's say where y is equal to 3x to the power of 4, hopefully by now you're very clear about how to find or how to differentiate that function. In other words, how to find dy by dx. Just do that do that in your book now. Pause the video if you need time to do it. Hopefully you're clear. You're going to take the power, multiply it by the coefficient, and then take away 1 from the power to give you something like that. So what we call this is the first derivative, or the first order derivative for the function. What it actually means is it's a way of representing the gradient function of this line or this function over here. That should be quite clear to you by now because you've done it for the last week or so. You find the first derivative by differentiating the original function in order to find the gradient function, which basically describes the gradient of every point on the line. What we're looking at today is second order derivatives. Second order derivatives tell you about the gradient function because they are found by differentiating the gradient function. So what we do is we're going to take our first order derivative and we're going to differentiate it again. And we call this, or we write it as d2y by dx squared. This is called the second derivative or the second order derivative. So again, I take my power and multiply it by the coefficient, and then I subtract 1 from the power. But what this means is this is the rate of change of the gradient function. So it's describing how much the gradient function is changing, how much this function is changing. By the way, rate of change is just a different way of saying gradient. So it's basically saying the gradient of the gradient function. So let's look at an example, number 14 here. So it says, given that y equals 3x to the power of 5 plus 4 over x squared, find dy by dx and d2y by dx squared. So I want you to pause the video and have a go at this on your own first. Press play when you're ready for me to go through it. So part A, now in order to differentiate this, I'm going to write it nicely. What that means is I'm going to write the x squared, which is the denominator, as a negative power. Doing this will make it much easier to differentiate. Now that I've done that, dy by dx is equal to 3 times 5, 15, subtract 1, so it's the power of 4, and then positive 4 times negative 2 is negative 8, x to the power of negative 3. So that's my first derivative. If you got that right, give it a tick. If you got it wrong, you may need to watch again how I did that. For B, it's asking me to find the second derivative. So I'm going to take my first derivative and I'm going to differentiate that. So d2y by dx squared, I'm going to do 4 times 15, which gives me 60, x, and then 1 less than 4 is 3. And then I'm going to do negative 3 times negative 8, which is positive 24, x to the power of, and then 1 less than negative 3 is negative 4. And that is my second derivative. Hopefully you can see there's nothing really very new here. It is just doing the same thing once more, having first differentiated. So make sure you've written notes there, and then we'll do one more example. So this example is the same, except rather than differentiating y with respect to x, we're differentiating f of x with respect to x. So you can see the notation is a bit different, but it means the same thing. The only other thing is that arguably this is a little bit spicier, this f of x. So they've given us f of x equal to 3 root x plus 1 over 2 root x. I'm going to write that nicely as 3x to the power of a half plus a half x to the power of negative a half. To be really clear, this bit, that's the same as 1 over x to the power of a half, which is the same as 1 over root x, which as you can see is what we have here. If you need to rewind that so that it makes more sense, then please do. And finally, just to avoid any confusion, a half is what we have here, times y 1 over root x obviously gives you 1 over 2 root x, which is what the question is saying. So this is my starting point. For part A, where I'm finding f dash x, I'm going to do a half times 3, which is 3 over 2, x to the power of negative a half. And then I'm going to do negative a half times positive a half, which is negative 1/4, x to the power of negative 3 over 2, because that's 1 less than negative a half. So that's my first order derivative done. If you need me to explain that again, obviously just pause the video and rewind what I've just said. Part B, second derivative. Again, it's negative a half times the coefficient, which is 3 over 2. And that is negative 3 over 4, x to the power of negative 3 over 2. Next part, negative 3 over 2 times negative 1 over 4. Well, negative 1 times negative 3 is positive 3 over 4 times 2 is 8. And I've got x, and then taking away 1 from this gives me negative 5 over 2. And that's the second order derivative there. You can hopefully see how important it is that you're fluent with indices at this point. Like even right at the beginning of the video, turning this equation into this one, you have to be clear that 1 over 2 root x is the same as a half x to the power of negative a half. Because if you write it like this, differentiating it becomes much easier. So if you need to rewind any parts to get your head around them, then do it now. Otherwise, make sure your notes are clear and read show my homework so you know exactly what you're supposed to be, which questions you're supposed to be doing.